Okay, these are the notes for dividing radicals. All right, so we've done adding, subtracting, multiplying, and now the last thing to do is dividing. All right, this gets a little tricky, so just pay attention. And again, you can always go back and watch this video as much as you want. Okay, the number one thing with dividing radicals is you cannot have a radical denominator. All right, so if you cannot have a radical denominator, sorry, let me go back to that. All right, so if you cannot have a radical denominator, then we have to be able to get rid of this radical 3. Okay, so let me pull it back up here. There it is. Okay, so right now we have a problem with this. It's radical 10 divided by radical 3, and we have a radical on the bottom. Okay, so we have to get rid of this radical 3. All right. The only way to get rid of a radical is to multiply it by its exact same radical. So if I had radical 3 and I multiplied it by radical 3, that gives me a perfect square. That's radical 9. Well, that's a perfect square. That just turns into 3. All right? So what I'm going to do is take this fraction and I'm going to multiply it not only by radical 3 on the bottom, but by a radical 3 on the top. A radical 3 over a radical 3 is equal to 1. So what I'm really doing is multiplying this fraction by 1. That way it doesn't really change its value. Now, when you multiply radicals, we already covered this, you multiply what's on the outside by what's on the outside. There's really a 1 here and a 1 here, but that doesn't really matter. And then what's on the inside by what's on the inside. So a radical 10 times a radical 3 is a radical 30. A radical 3 times a radical 3 is a radical 9. But if you already know that that's just going to turn into a perfect square and it's a 3, then just go ahead and write radical 30 over 3. Now, make sure everything is in its simplest form. So I have a radical 30 right here. Can I break down 30? I'll put it over here. The only thing you can get out of 30 is a 3 and a 10. And a 10 is a 2 and a 5. Well, you can't get any pairs, so guess what? The square root of 30 is already in its simplest form. There's nothing you can do. You cannot simplify that. All right, so that is your final answer. Now, you do not do 30 divided by 3 and say the answer is 10. This is a radical 30 on top. That's a regular 3 on the bottom. Those two don't go together. So your final answer is radical 30 over 3. That's the best you can do. And number one rule is we got rid of the radical on the bottom. You cannot have a radical denominator. All right. And the term is called rationalize the denominator. All right. So really what you just did, rationalize means you basically got rid of a radical denominator. Okay. All right. Let's look at the next one. All right. So it looks like I have a radical 8 on the bottom. The only way to get rid of a radical 8 on the bottom is to multiply it by a radical 8. Well, if you multiply the bottom by radical 8, multiply the top by radical 8, because radical 8 over radical 8 is just 1. You just multiply it by 1. Now, go ahead and multiply the top. That's a 7 times 8 inside the radical, so that's 56. X is all by itself. So that's radical 56x. Radical 8 times a radical 8 is really just 8. If you want to just go ahead and put 8, you could put 8. It's the square root of 64, but that turns into 8. So I have a denominator of 8, which is perfect. All right. Now the only other question is, can I break down this 56? Well, couldn't we break it down into 7 and 8? We know 7's prime, circle it, but 8, can't we get a 4 and a 2? And can't we get a 2 and a 2? So I have a pair of 2s. So where does that 2 go? On the outside. What goes on the inside? Remember, you got rid of the pair of 2s. You had a single 2 and a single 7. 2 times 7 is 14, but something else still goes inside. Remember, you had that single x. Now, if you left this answer like this, I'd probably take 1 point off. You have a real 2 and a real 8. Those are not radicals. Can you simplify the fraction 2/8. Yes, you can simplify it to 1/4. So really your final answer, you can put a 1 in front of the radical, but you don't have to. It's radical 14x on the top, and 2/8, remember, reduces to 1/4. That's the best you can do. You cannot reduce the 14 and the 4 because the 14 is inside of a radical. Okay? All right, look at the second example. We have a problem. The problem is the 6, the radical 6 on the bottom. You can't have a radical denominator. The only thing that gets rid of a radical 6 is multiply it by another radical 6. If you multiply the bottom by radical 6, do the same thing to the top. So radical 2 times radical 6 is radical 12. Radical 6 times radical 6 is the square root of 36, but that's a perfect square. It turns into 6. Now, again, you cannot do 12 divided by 6 is 2. That is not 12. That is a radical 12. But can you simplify 12? Can't you do 4 and 3? But why do we like 4? Pair of 2's. So we have 2 on the outside, 3 on the inside. So right now your answer is 2 radical 3 over 6. I'd probably take 1 point off because look, you have a 2 and a 6. Those are not radicals. Those are real numbers, 2 and a 6. Can't you reduce 2/6 to 1/3? So your answer is, you can put a 1 in front of here if you want to, but you don't have to. Radical 3 over 3. And again, the 3's don't cancel. Why do the 3's not cancel? Because on top, that's a radical 3. On the bottom, that's a regular 3. Those two don't go together. Okay, on number 3, you'll sometimes see problems where they put the radical and the entire fraction is inside the radical. That's the same as if you separated them. So if you want to just separate them, it means the same thing. Okay, well, we still have a problem. You cannot have a radical 6 on the bottom. What's the only way to get rid of a radical 6? Multiply it by a radical 6. Whatever you do to the bottom, you do the exact same thing to the top. It's like multiplying by 1. Okay. Up top, radical 5 times radical 6 is radical 30. I think we already established a minute ago that you can't simplify that, so you might as well leave it. Radical 6 times radical 6 is radical 36, but again, that's a perfect square. It just turns into 6. And again, you cannot do 30 divided by 6 is 5 because that is a radical 30. That's the best you can do right there. All right? All right, again, we'll just look at a couple of these here. Number 15, same thing. If you wanted to do radical 1 over radical 6, again, the problem is the 6 on the bottom. All right, well, multiply it by radical 6 over radical 6 again. We just did a radical 6. All right, radical 1 times radical 6 is radical 6. Radical 6 times a radical 6 is square root of 36, which is 6. Now, unless you can break down 6, but the only thing you can get out of 6 is a 2 and a 3, so you can't break down radical 6. So the 6's don't cancel because one's a radical 6, one's a real 6. That's the best you can do. All right? All right, look at number 17. Again, if you don't want to write it the way they have it and you want to separate it, go ahead. And again, who's the problem? The radical q or the radical 12? It's the radical 12. Multiply top and bottom by radical 12. Okay, so the only way up top to do radical q times the radical 12 is just 12 times q. It would be radical 12q over, remember, radical 12 times a radical 12 is just 12. Okay, the 12's don't cancel. Can you simplify radical 12? Can't you do 4 and 3? Why do we like 4? Pair of 2's. Okay, so we got 2 on the outside, single 3 on the inside. So outside is a 2, inside is a 3, but who else is on the inside? Don't forget, you had that single q. Over 12. I would probably take a point off because something can still be reduced. Look at the 2 and the 12. Those are outside the radical. You can reduce 2/12 to 1/6. So really your final answer should be, you don't have to put a 1 in front of the radical, 3q over 6. That's the best you can do. Okay? All right. I know I'm not going in order, but that's okay. We'll finish all of them. We might as well. Okay, separate it if you want to. We just simplified radical 12. But you should notice something about this denominator. You don't need to multiply it by radical b squared over radical b squared because radical b squared, that's a perfect square. How many b's do you have here? You got 2. Is that enough to get out? Yeah. So guess what? This just turns into b. You don't have to multiply it by anything. Now, we just simplified the square root of 12 a minute ago. Wasn't it 4 and 3? What does 4 give you? A pair of 2's? So it should just be 2 radical 3 over b. You really didn't even have to do any multiplying on that one because that was already a perfect square. All right, let's look at the last few. You may see something like this. This is just multiplying and then simplifying. So when you multiply fractions, remember, numerator times numerator, so that's the square root of 6. Denominator times denominator, that's the square root of 21. The problem is we got a denominator on the bottom. So how do you get rid of a radical 21? The only way to get rid of it is multiply by radical 21 over radical 21. Okay, so on the bottom, a radical 21 times a radical 21 should just be 21. You can multiply 21 times 21 and do the square root of that, but you don't have to. That's just going to be 21. If you want to use your calculator, 6 times 21 on the top is 126. So the question is, can you simplify 126? Well, let's see if we can't break it down. Couldn't we use 6 and 21? What do we like about 6? 3 and 2? Okay, what do we like about 21? 3 and 7? What do we have a pair of? Looks to me like we have a pair of 3's. So I got 2 3's. So I'm going to put 3 on the outside. I got a 2 and a 7 on the inside. 2 times 7 is 14 over 21. Once again, I'd probably take 1 point off. Can you simplify the fraction 3 over 21? Does 3 go into 3? Yes, 1 time. Does 3 go into 21? 7 times. There's your answer there. All right. All right. 18. Again, if you don't like writing it that way, you can do it this way. And technically speaking, this 4 could come out because 4 is a perfect square. If you wanted to do that first, it'd make it easier. It doesn't matter. The problem is the 5. How do you get rid of a radical 5? Multiply top and bottom by radical 5. So up top, inside we got 4h times 5, so that should be 20h. Bottom is radical 5 times radical 5. That's the square root of 25. That's just 5. So the last thing we can do is see if we can't simplify 20. Well, again, if we had simplified the 4 earlier, it would have been easier. Couldn't we just do 4 and 5? And why do we like 4? Pair of 2's. So who goes on the outside? 2 on the outside. 5 on the inside. And then don't forget there was an h on the inside divided by 5. Do the 5's cancel? No, because one's a radical 5, one's a real 5. All right? And last one. Same thing. This is almost just like number 19. If you were to take these out individually, you don't need to multiply top and bottom by 4m to the 4th. Look at what 4m to the 4th is. Everything's a perfect square. 4, the square root of 4 is just 2. And how many pairs can you get out of 4 m's? Wouldn't that be 2 pairs? So there's no radical left. You didn't even have to do any work on this one. So your answer is the square root of 45 over 2m squared. The only question is, can you simplify the square root of 45? Well, shouldn't we use 9 and 5? If I use 9 and 5, I get a pair of 3's. There's my 3. So 3 on the outside, 5 on the inside, 2m squared. And that's the best we can do. All right? All right, so you can look through this as many times as you want. There are problems on Schoology now. They're multiple choice. Same thing, just take your time. So as soon as you're done looking at this, go to the very next item, and it'll be the problems on Schoology. Just make sure you guys get those done before 7:45 a.m. the next morning. All right, see ya. Have a good weekend.